Okay, today we are going to be reading pages 61 through 65 in our textbook about precipitation. And this little lab that you're seeing right here is something that we will be doing, and that'll be super fun. But I'm going to get to the reading down here. In Arica, Chile, the average rainfall is less than 1 millimeter per year. But in Hawaii, the average rainfall on Mount Waialeale is about 12 meters per year. So as you can see, rainfall varies greatly around the world. And I just want to show you. So 1 millimeter would be like 1/10 of 1 centimeter. So just that first little tiny line there. And 12 meters would be 12 meter sticks, so 12 of these. So from 1 millimeter in Arica, Chile to 12 meters in Mount Waialeale is a pretty significant difference. Water evaporates from every water surface on Earth and from living things. This water eventually returns to the surface as precipitation, which we talked about in our last section. Precipitation is any form of water that falls from the clouds and reaches Earth's surface. So rain, sleet, snow, hail, any of that would be considered precipitation. Not all clouds produce precipitation, however. For precipitation to occur, cloud droplets or ice crystals must grow heavy enough to fall through the air. So when you see clouds in the air, you're actually seeing water droplets that are suspended in the atmosphere. And it's only when those droplets get heavy enough that you get precipitation. One way that cloud droplets grow is by colliding and combining with other droplets. As they grow larger, they move faster and collect more droplets. And finally, the droplets become heavy enough to fall out of the cloud as raindrops. And this picture here is really important. It shows you a comparison. These are not actual sizes, but it compares. And it says this little droplet, which is 0.02 millimeters, which means if I took that 1 millimeter again, and let me put my thumb, so that is 1 centimeter. So that little tiny dot, that little mark down there is 1 millimeter. And so this is 0.02 of those. So that means it would take 50 of them to be as wide as that 1 millimeter. That is a cloud droplet. Mist droplets, which are sort of when you walk out, you sort of feel them touching your face, but it's not really falling. Those can be anywhere from 5 thousandths of a millimeter to 5 hundredths of a millimeter. Then bigger droplets might be a drizzle droplet, which is anywhere from 5/100ths to half of a millimeter. And a raindrop can be anywhere from a half of a millimeter, and I'm trying to find something to point with, a half of a millimeter, which again, this is just this little mark right here. This is 1 millimeter. And then it can be all the way up to 5 millimeters, so a half of a centimeter. Raindrops can be that big. Those are those big, hard raindrops. They hit, you can kind of feel them, they hurt. So those are the different sizes compared to each other. So rain can be, it could be drizzle, it could be mist, it could be an actual raindrop. Those are all forms of precipitation. Then, of course, sleet, which we'll talk about, snow, hail, which are other forms of precipitation, which we're going to read about in a minute. Types of precipitation. In warm parts of the world, precipitation is almost always in the form of rain. In the colder regions, precipitation may fall as snow or ice. We're very used to that here in the Midwest. Common types of precipitation would be rain, sleet, freezing rain, snow, and hail. Freezing rain is actually not what you think, but again, we'll talk about it. The most common kind of precipitation is rain. Drops of water are called rain if they are less than 0.5 millimeters in diameter. Precipitation made of smaller drops is called drizzle, and precipitation even smaller droplets is called mist. Drizzle and mist usually fall from stratus clouds, those sort of layered clouds that we see on those gray days when it's like, it can last for several days. Now, sleet. Sleet starts out as raindrops. It says sometimes a raindrop will fall through a layer of air that is below zero, the freezing point of water. So it starts out as liquid rain, but as it falls, it freezes into a solid particle of ice. Ice particles smaller than 5 millimeters are called sleet. And you usually sometimes see it. It almost looks like, to me, it always reminds me of like a slush from like Sonic or something, like little balls of ice on the ground. Those are sleet. Freezing rain actually it stays rain the whole way through. So sometimes raindrops falling through the cold air near the ground do not freeze in the air. They stay rain all the way to the ground, but instead they freeze when they touch a cold surface. This kind of precipitation is called freezing rain. In an ice storm, a smooth, thick layer of ice builds up on every surface. The weight of the ice may break tree branches and cause them to fall into power lines, causing power failures. Freezing rain and sleet can make sidewalks and roads slippery and dangerous. And just to give you guys an idea, These are what, this is what droplets of sleet would look like here, okay? So it looks like little tiny ice pellets. And then freezing rain is when it is all the way to the ground, but it freezes when it hits a cold surface, and it freezes in the air. And a lot of times that's what you'll see covering tree branches. Sometimes you'll see it covering, lots of times you'll see it covering cars. This is quite a bit of, let me go back just to the image here. Um, so that could be freezing rain. A lot of times it's usually more of a thin layer, but the problem is that it can make the power lines really heavy and they can break. So we talked about rain, we talked about sleet, we talked about freezing rain, and there's again rain, there's freezing rain. And we're gonna talk about snow. We again know about snow. Snow. Often water vapor in a cloud is converted directly into ice crystals that's up in the atmosphere. Excuse me, called snowflakes. Snowflakes have an endless number of different shapes and patterns, all with, you know it, 6 sides or branches. Snowflakes often join together in large clumps of snow in which the 6-sided crystals then are hard to see. And I know that if I were to search snowflakes, you guys could, there's actually really cool videos that you can find on YouTube about snowflakes forming, but you know what a snowflake is. And then hail. Round pellets of ice larger than 5 millimeters in diameter, they're pretty big, are called hailstones. Hail can only form in a cumulonimbus cloud. It forms up in the cloud itself. It doesn't happen as it falls. Hail forms inside a cumulonimbus cloud during a thunderstorm. A hailstone starts as an ice pellet inside a cold region of the cloud, and then a strong updraft will carry the hailstone through the cold region many times. And every time it goes up, a layer of ice will get added and it may come down. And then as it goes up, another layer of ice gets added. And so each time the hailstone goes through the cold region, a new layer of ice forms around it. Eventually, the hailstone becomes heavy enough to fall to the ground. If you cut that hailstone in half, often you see shells of ice like the layers of an onion, as shown here in figure 22. They can grow, because hailstones can grow quite large before finally falling to the ground, they can cause tremendous damage. And if you look at, you can find really cool images online, and you can see they can get quite large. But if you cut into them, you'll end up seeing the different layers, as it formed, of the transparent ice and the, this is a good one, of transparent and then clear, or transparent, translucent, transparent, because each time it's gone up into the cloud again and had a new layer. So those can be pretty damaging, as you can imagine, to cars. And if you're out and you're unprotected, they can be very dangerous depending on the size. So there is, again, you have this pellet that's going up and down and a layer adding. Now, this is showing us something called cloud seeding. We're going to talk about modifying precipitation for, as long as people have tried to bring the rain. There has been they have been trying to produce rain. They've been doing rain dances, but there are some scientific ways that they've actually approached trying to get rain to occur. So modifying precipitation. Sometimes a region goes through a period of weather that is much drier than usual. Long periods of unusually low precipitation are called droughts. Droughts can cause great hardship. Since the 1940s, scientists have been trying to produce rain during droughts. One method used to modify precipitation is called cloud seeding. It's not very effective, but basically in cloud seeding, tiny crystals of silver iodide and dry ice. So the silver iodide is the particle that's super frozen, it's super chilled by the dry ice, are sprinkled into the clouds, hoping that cold surface, because remember, for cloud formation, for precipitation or condensation, you need to have lower temperatures and you need to have particles. So they're adding these chilled particles by adding the silver iodide and the carbon dioxide. They sprinkle them into the clouds. Many of the clouds already have the droplets of water, which are super cooled below zero. The droplets won't freeze up there, though, because there aren't enough solid particles around which the ice crystals can form. So their hope is that putting the super chilled silver iodide will be the particle. Water vapor can then condense on the particles of silver iodide, forming rain or snow. The dry ice then cools the droplets even further so that they will freeze without particles being present. However, that has not been very effective in producing precipitation. How do we measure precipitation? It's pretty simple. You probably have seen this. Measuring precipitation, there's a couple of ways to measure various amounts of rain or snow. We measure precipitation with a couple of instruments, including something called a rain gauge and just a plain old measuring stick. So snowfall is easier to measure. Snowfall is usually measured in 2 ways: using a simple measuring stick or by melting the collecting snow. So if we want to know, you'll hear like how many inches of snow you'll get. You'll basically just put this in the ground and you would say, oh, that's 6 inches of snow. You can measure it quite simply that way. Or they usually melt it down. On average, 10 centimeters of snow, if you measure 10 centimeters, would melt down to be about the same amount of water as in 1 centimeter of rain. But it depends on how tightly the snow is packed. Light, fluffy snow will contain far less water than that heavy, wet snow. When we are collecting rain, this is a rain gauge. Basically, it's like a graduated cylinder with a funnel at the end. And we'll talk about what that looks like. An open-ended can or tube that collects rainfall is called a rain gauge. The amount of rainfall is measured by dipping a ruler into the water or by reading the marked scale, like on a graduate. To increase the accuracy of the measurement, the top of the rain gauge may have a funnel that collects 10 times as much water as the little tube itself would. But then what they do is when they get the measurement, they would divide it by 10. So since this is 10 times as wide, if I got 10 centimeters of rain, I would divide it because it collected 10 times as much, telling me it's 1 centimeter. To increase the accuracy of the measurement, the top of the rain gauge may have a funnel that collects 10 times as much rain as the tube alone, as shown in figure 24. The funnel collects a greater depth of water that is easier to measure. To get the actual depth of rain, it is necessary to divide by 10. The narrow opening of the tube helps to minimize evaporation, and also sometimes those droplets don't make it in. So if this is collecting 1 centimeter of rain, but it's 10 times as wide, you'll get 10 centimeters. But that will tell you when you divide by 10, you'll get 1. So that is it for this section. I will see you guys on the next one. Good luck.